All right, hello. So let's continue where we left off last time. Right, so if you remember, I had this triangle that I was trying to have a camera rotate all about, but it is not working because I have a severe fundamental misunderstanding as to how quaternions work. So I was under the impression that I can just go ahead and adjust the individual components of the quaternion like this to get the rotation working, which it doesn't work that simply, because I'm basically neglecting the W component in every sense of the way, so I need to consider that. So I can't just do that. What I need to do is be able to, a couple things actually. I want to be able to multiply quaternions, and I want to be able to take an Euler rotation and convert that to a quaternion. So here's my quaternion union. Yeah, so let's just make a couple functions here. All right, so first thing I want to do is make a function that will be able to multiply quaternions. And it is going to take in two quaternions, Q1, Q2, and multiply them together. So I need to make a quaternion, and that's what I'm going to return. And then so in here, I'm going to calculate the product of Q1 and Q2 and set that value in Q. So to do that, I have to use the internet. All right, so let's Google search multiply quaternions. And so if we look at the Wikipedia page, all right, so yeah, basically this is the formula right here that I'm looking for. But that's not 100% complete because I also have to consider these identities here. So yeah, so I'm just gonna copy this for now. Actually, that's probably an image. It's not gonna work. Yeah, that did not work. All right, so I'll just be doing a lot of flipping. So basically, this is the W component. I think it's just backwards. W, Z, Y, and then this is X. Okay, so Q dot X is this thing here. So A is the X component, D is W, B is Y, C is Z. All right, and then the 1 is the first quaternion, the 2 is the second quaternion. So the X component is there we go. Sorry, webcam's not the best. Okay. All right, carrying on. So again, trying to calculate the X component of my quaternion, and I need to use this right here, I believe. Is that okay? Or actually, maybe it's W, X, Y, Z. I think it's X, Y, Z, W. I'm going to try it this way and then see. So, this EuclideanSpace.com is usually pretty good. Yeah, so there's the identities I need to consider. And then here's the formula. So, yeah. W, Z, Y, and X. Yes, let me try that as if it's backwards. So X, Y, Z, W. So I basically want Q1's X plus or times Q2's W where are we at? There we go. q1.x times q2.w, and then I'm going to add that to q2z, or no, q2's.y, no, q1.y times q2.z, and then that's going to be a subtraction of q1.z times q2.y. And then I'm going to add q1.w times q2.x, right? Yeah, a is x. So now I need to consider, so x is basically I, w is 1, z is j, z is k. So right for this first one I have I and 1. So anything with w is going to be positive, so that stays positive. And then so now I have j and k. So jk is positive, so that stays positive. And then now I have k and j. K and j is negative, so that should be negative, which it is. And then anything with w is positive. All right, so that seems good. Now the y component is going to be this one. So that is q1.x times q2.z minus q1.y times q2.w. And so anything with a w should get positive. And then I'm going to add that to q1.z times q1.x, no, q2.x. And then add that to q1.w times q2.y. Okay, so this one we have a k and an I. So k, I is positive. So yeah, that's good. So this one is a I and a k, which is negative. So that should be negative here. Wait, I and a k, yeah. So that should be negative. So then that is a w, so that's positive. And then I believe I already checked that, which is ki is positive. Yeah, okay. So far so good, I think. All right, so now the z component is q1.x times q2.y plus q1.y, q2.x plus q2.z, q2, or no, so q1.z times q2.w, and then minus q1.w times q2.z. All right, so now we got an I and a j. So j is positive. Then we got a j and an I. ji is negative, so that should be a negative, I believe. And then we have here a k and a 1, which is positive, and a 1, which should also be positive. And the last part, the w component, is this one here. So we got q1.x times q2.x minus q1.y times q2.y minus q1.z times q2.z minus q1.w times q2.w. All right, so that's that. All right, so then again we have an I and an I, which is positive. No, is that right? No, that's wrong. Yeah, anything with itself is going to be negated. Yeah, so I is 1 times I. It doesn't, yeah, I squared. Yeah, anything times itself is negative, so that's going to be negative. Then we have that, which is negative on a negative, which is positive. Right? No, that's not right. That should be negative. Yeah, so that's negative, that's negative, that's negative, but then because these are using W, that should be positive. All right, so I believe that's it. I believe that's how you multiply a quaternion. I forgot to give this function a name. Okay, so that is how you do that, I hope. All right, so then what I also want to be able to do is take an Euler rotation and convert it to a quaternion. So I'm going to return a quaternion. I'm going to call this rotation to quaternion. This is going to take in a vector 3 for the axis that it's going to rotate around, and then a float for the angle for how much it is going to rotate. And let's see, into quaternion. And yeah, that's pretty much the formula I need right there. Although I do believe that my axis is going to be assumed to be pre-computed with the cosine, so I don't think I need to actually take the cosine of any of that. So I basically need the cosine of the half of the angle and then the sine of the half of the angle. So first let's calculate half of what the angle is. So we'll call this half ang is equal to the angle times 0.5. And then we need the sine and the cosine of that. So sine half ang is equal to the sine of half ang. And then the cosine half ang is equal to the cosine of that. And then I need a quaternion to return. All right, so the W component, let's just go in order, x, y, z. So q dot x is sine of the half ang times the angle of x, or the x component of my angle. So yeah, sine half ang times angle dot x, nope, axis dot x. And then the y and the z components are essentially the same thing. And then the w component is simply just the cosine half angle. All right, so I got a rotation to a quaternion, and then I got an actual quaternion multiplication. So then what I want to do is make an actual rotate function. So static, we'll call this, that's going to not return anything. It's going to rotate. All right, so first thing it's going to do is take in a pointer to a quaternion. So that will be the quaternion that you're rotating. And then it's also going to take in an axis and then an angle. All right, so this is easy because I got the work here done for me. So what I want to do is first make a rotation or a quaternion out of the rotation. So we'll call this rotate quaternion rot. equal to rotation to quaternion. It's going to take in the axis, it's going to take in the angle, and then I am going to say that the quaternion that you're rotating is equal to itself. Actually, let's call it multiply. So itself times this rotation quaternion that I just made. And that's what I want to return. However, before I do that, I want to normalize it. All right, I want to reduce it to the length of 1. So I need a couple more functions here. Let us make static f32 length. So I need to get the length of a quaternion. And that is easy because Pythagorean's theorem tells us that all we need to do is return the square root of q dot x squared plus q dot y squared plus q dot z squared plus q dot w squared. Okay, so q dot x plus q dot y plus q dot z plus q dot w. Okay, and then once I can get the length of it, I can normalize it. So static void, we'll call this normalize, and it's going to take in a pointer to a quaternion. And so first we need to calculate the length. So call this len is equal to the length passing in q. And I don't want to divide by 0, so let's just do a quick if statement. And this probably isn't the most efficient way to go, but I'm not worried about efficiency right now. I'm worried about end result. So if the length does not equal 0, then it's safe to divide by it. Otherwise, we'll just do something else. So the q's x is equal to, well, actually we'll just divide equals by len. And we want to do the same for the other 3 components. All right, and if the length is 0, I just want the quaternion itself to just be 0. There we go. All right, so now that I could normalize it, it would be a good idea to do that after I rotate it. So let's normalize Q, and that should be it. So back here where I was just simply adding and subtracting from the components of the quaternion, I want to call my new rotate function. I'm going to pass in the address of the camera's orientation. I am going to pass in the axis to rotate it around, which when I'm moving up and down is going to be the x-axis. And then the amount. So let's just do 0.01, that might be really slow. All right, so when I'm going up and down, I want to do this. And I'm getting errors because rotate. Mathematics 167. Oh, that's because we don't need to return it. And on 239, 293, it's supposed to be vector 3. There we go. Okay, so if you notice now when I hold the down arrow, my triangle goes below, but if I keep holding it down, it should come back around to the top of the window. And it does, awesome, it's working. Okay, so let's now do lateral rotation. And I can just use the same function I used here. And instead of rotating around the x-axis, I'm going to rotate around the y-axis. And I probably want that to be positive. All right, so far so good. Let's see if it comes back around. And it does. Awesome. Okay, so one more thing. Let's just rotate around the z-axis. All right, and that is working as well. Cool, so I can move forward, I can move back, I can move well, up and down. I can move left and right if the angle's right. In fact, that's the next thing I want to fix, is I want to be able to, when I'm looking down or up, I want to move that direction, the direction that the camera's pointing, and not just simply along the solid Z, the world Z or the world x-axis. Okay, so to do that, I want to be able to do a couple things with my vector 3 here. I need to be able to add vectors, and I also need to be able to scale my vector by a constant amount. So let's see. Okay, so let's start here. All right, so I don't want to do it there. Let's do it here. All right, so we'll call this static. It will be a vector 3 add. It'll take 2 vector 3s. I'm going to pass them in by address. And we're simply going to return a vector 3 that is the sum of all the components. So we'll take v1.x plus v2.x, v1.y plus v2.y, v3.y plus v3.y. No, wait, where did v3 come from? You know what I meant. Okay, so 1, 2, y, y. Okay. And then I also want to be able to scale a vector. So static vector 3 scale. So this is going to take in a vector 3 and a float for the amount that it's going to be scaled by. And then we're just going to simply return a vector 3 that is v1.x times amount, v2.x, nope, still v1, v1.y times the amount, v1.z times the amount. And yeah, I'm going to go ahead and add operators for those, just because it's convenient. Plus and then so simply just return the addition of v1 plus v2. And this is going to be operator star f32 the amount, and we're just going to scale v1 by the amount. All right, I did a lot of coding with little compilation. Let's see if I got a bunch of errors. Oh my goodness, I don't. All right, so I need to change these to add a vector to the camera's position. But to calculate what that vector is, I need to come down here. So once I update what the camera's view is, I can now extract the camera's forward, the left or the right and the up vector from that view. All right. So let's say the camera dot I believe it's, is it right up back? I don't know. We're gonna figure this out. So let's say the camera, actually I think it's right first. So let's say the camera's right is equal to the camera's view dot m2, because I want to access it in a 2D array manner. First of all, this is going to be a vector. And then so the x position is, I believe it's just 0, 0. And then the y is, you're just moving down. So the 0 stays the same, but the 1 changes. I'm probably wrong about this. Okay, and then I believe the up and the forward vector are very similar. So up and forward. And so I believe they're just one column over, so I just changed those. Wait, I feel like I'm wrong. Well, I'll find out soon enough. All right. So now instead of just adding to the z component, I'm going to add to the whole vector. I'm going to say equals, wait. I'm going to add a plus equals operator. Is it the same thing? No. Okay, so plus equals should be void. And then I want to say that v1.x plus equals v2.x. All right. So I think I can now just say plus equals camera dot forward, and then I want to multiply that by some amount because otherwise it'll be going way too fast. So let's just say 0.1. Oh my goodness, the moment of truth. Oh, it's working. Okay, I think it's going backwards, but it's fine. Ooh, and I also want minus equals as well. Oops, what did I just do? Okay. It's not quite working. It's going opposite. Why is that? Oh yeah, you know what? I think, yeah, because this part of the matrix is actually the back vector, so I want to invert it if I want to go forward. That's still not right. But I do need to invert that. But actually, I still feel like these are backwards here. So I think this is supposed to be 0, 2, 1, 2, 2, 2. Is that right? No. Let's look it up here. So right, up, back. So that's 0, 1, 0, 0, 0, yeah, so 0, 1. Okay, yeah, let's do this. Let's check the right vectors. Okay. So it's weird. It seems to be working, but like in the opposite way. So like if here, so if I'm looking down, I should go down, but I'm going the opposite direction. Oh, actually, you know, I think it's working. I think I just got these backwards. And then if I change that to that, is that right? Yeah, that's better. And then also my rotation is wrong too. So I want up to be negative, and that should be positive. So the other one. There we go. Still my rotation left and right is backwards. So that should be negative, positive. Still not quite right. Yeah, the up and down part's right, but the left and right is not. And I think probably these need to be reversed as well. Okay, so then I think I just need to reverse these. Yeah, that, okay, that's working. Yeah, so now I can move pretty much where I want. I can not really rotate side to side quite yet. Why is that? Hold on, maybe I can. Oh, you know what? I still think I got these backwards here. So the forward, no. Oh yeah, that the problem is I'm still hard coding these, so I don't want to use these. I want to use the camera dot right for the up and down. And then this, so for left and right, I want to pivot around the camera's up vector. And then here for the forward movement, I mean the forward rotation, I want to rotate around the forward vector. Oh yeah, there we go. That's what I was looking for. Okay, so yeah, now I'm pretty much able to maneuver however I want around this triangle. Now I just noticed DirectX 11 does backface culling by default, because I didn't do anything to say don't render this triangle from the back, but if I go behind it, it disappears. Really weird, but whatever. I probably want backface culling anyway, so it's not a huge issue. But yeah, I'm really happy with what I got right now. So yeah, I just wanted to fix the issue I had last night and then make a little bit of progress, which I did. So I'm happy with that, and I'm going to wrap it up there. Thank you everybody for joining me. I will see you next time. Bye.